Alex again. Welcome to part 2 of our interdisciplinary studies where we're building a cigar box ukulele. Sorry it's been so long since part 1. I've had a whole lot of projects going on, and I actually have most of this series recorded, but the video files are all over the place. So I finally got around to digging them all out and putting them in some kind of logical order. Now I'm trying to keep these video segments down to around like 10 minutes or so. This second part is just going to introduce the concept of using CAD or computer-aided design as part of the design stage. Now I first started using CAD back in 1996, 1995, something like that, when the packages were incredibly expensive and really just available to like engineering professionals and students, and required some pretty beefy computers to run, at least for the graphical versions back then. But now there's a ton of choices, both paid and free. So many so that it's kind of confusing what you're supposed to use. Now the most popular one these days amongst like tinkerers and students and startups and that type of thing tends to be Fusion 360, but I thought that was a little bit complicated to jump into for a series where I'm trying to give introductions to this sort of stuff. And honestly, their workflow is a little bit difficult and slows things down greatly. So the program I'm going to be using is one that I use to just do this sort of stuff when I want to just make a 3D model of something that's basically just like the equivalent of sketching it down on a piece of notebook paper, except it's rendered in 3D so you can turn it around, see how things fit, try stuff out. And if you're not sure if something is what you like, or you're not sure what it's going to look like in real life, just looking on a computer screen, you can export that to an STL file and print it up on your 3D printer and get a real copy in your hands and see how it does. And that sort of workflow between like conceptual and then visual and then physical is what I really like about drafting things up in a CAD, as opposed to trying to jump right from two-dimensional sketches on a piece of notebook paper to a three-dimensional physical object. It's that nice missing link in the middle that'll kind of help you work out issues before they come up. So I'm going to be using 123D Design, which has unfortunately been discontinued, but if you see the workflow I'm using and you think that it's going to be useful, you can always dig up a copy online somewhere. It was free software, and a lot of its functionality has been rolled into Fusion 360. It's just you have to jump through a couple hoops to get to Fusion 360's historyless direct solid modeling mode, and even then the menus are a little goofy and it's a lot harder to work with. But if you're going to be using it in the long run, you could just skip the simpler DSMs and go right to that. It's free if you're a startup or a student, but if you play with it and you think it's too complicated and you can't find a copy of 123D, just look for another direct solid modeling program, or it might just be abbreviated DSM. Because it's a lot like just pulling down blocks and then carving them out. So if you're familiar with like the concepts of woodworking, which a lot of people are if you're watching a video on how to make an instrument, or if you just built things with Lego blocks when you were a kid, or you played Minecraft, it's pretty similar to a lot of that kind of stuff. So let me go ahead and show you just the rough sketching out process that I did for this project. And I edited it down to about like 8 minutes. Here we go. To start off with, I just defined a grid that's 24 inches by 12 inches. Sorry, I'm going to be using imperial measurements for most of this. And I wrote down the dimensions of our stuff. So what I'm going to start with is the neck. So the first thing I'm going to do is just pull a block, and this is going to be on right smack in the middle. For the length, it's going to be the width of the neck, so 1.5. For the width, we're going to start out with 24 and just see how that goes. And then the height is 0.75, and just drop that down here. Now if you want it to feel more wood, you can woodify it. Usually I find it most useful to make it clear. And then we're going to make a body as well. The length was 8.25, and then 9.75, and then 1.25. There we go. And what I'm going to do here is use the magnet tool on this surface to drop it right smack in the middle of this surface. And then I'm going to hit D to drop it down to the bed and make it clear so we can see that too. And that's going to be our basic ukulele. Now just to mark the bridge, I'm going to drop this block right in the middle of this. So I will shove this over this way and then check to see where we are. 6.4 is pretty close. I'm just going to nudge it that way a tad. About 0.75. That's going to represent our bridge. Here, let me make that a little bit more bridge looking for you. I'm going to pull the sides a little bit, and then I'm just going to hit C, something like this. And let me sink this down, and I'm gonna join these by adding them. I could always go back and slice that off later. This right here is just going to be marking the bridge for measurement against the end right here. And we want the distance between where our 0 fret or our nut or whatever it is going to be. I'm going to do that, and this will be our 0. Don't want it at the end, so maybe minus 11.5. Stick it right there. And the distance between our 0 fret and our bridge is going to be our scale length, which, as he said before, was going to be about, what was 14.75, so either 14 or 15. It really doesn't have to be exact because we're going to be laying out our frets anyway. So we can pretty much choose whatever we want. So let's say we want that to be 14 inches. We can whip out a calculator and say 14 minus 12.65. And we know we have to nudge it 1.35 in one direction. So I'm going to nudge the body. .35 inches that way. And now we can see how much extra room we need. If you recall, we needed at least like 4.5 or so for our tuners. This is 5.775, so we can ditch an inch off the end of that and probably be okay. So I'm going to hit P and push this in by 1 inch. And then I want to move this guy up. 0.75 would put a 1/4 inch of fingerboard off the top. And again, this is going to have to be our bridge height plus whatever the strings are. So let's just say we'll move that down by 1/8 of an inch. And then we can check with a measuring tool, take the surface of the guitar and the surface of that, and see that we have 1/8 inch there. I'm going to make this wood so that we understand that it's our neck. And then I'm going to push this down so that it's more reasonable, and look at the break angle of our strings. So let's check and see what height our nut is going to be. 0.87. Let's move that up a touch. And then I'm just going to sketch a line. Select this face, and that's going to be our first. And then we want it to be somewhere around the top of our, right there. And that's going to roughly be the break angle of our string. And we know that we have to notch this out for the body. So what I'm going to do is just copy paste our body and use that to cut our wood. Now I'm not sure how thick the top is, but we can always adjust that. And I'm going to push that down to where I think is reasonable. That looks about right. And then I'm going to select the neck and subtract this floating body from it to notch it out. Now for simplicity's sake, I'm going to hollow this cube. So I need to know how thick our edges are, which are 3/8. So we're going to hollow this out to a thickness of 0.375. I said 0.375. And like I was saying before, I think I'm going to put the sound hole up on the top facing the player. So I'm going to use this guy here, and I'll probably set it... Oops, that was not what I wanted to do. And I will probably set it roughly there-ish. And let's resize that. Maybe that, and look good, and just subtract it from the body. And we could always go ahead and add sound holes on the edges here, or even one right underneath the strings. Now let's represent our tuners somehow. They're like a 1/4 inch shaft, so 1/8 inch radius. And the shaft is about 1 inch tall. We've got that there, and then we'll just make a block 0.75 by 1.25 by 0.5. That's going to be the body, and then for the actual peg itself, now I know that's ugly, but it's going to let us lay it out. Now here's where CAD kind of comes in handy, because I can see right here that we're going to have problems with the shaft. So I'm going to take this end here and push it. And we'll end up with something that looks like that. And let me grab this tuner real quick. The hole on the bottom of our tuner, or the hole through where the string goes, is down about there. We can double check that by measuring. 0.15, and the actual tuner is 0.15-ish. And that's going to let us check our break angle, which is going to be slightly lower than the tuner because of the turns of the string. There we go. And then I'm going to copy paste the tuner. I'm going to draw a line on the bottom of the tuner itself. Select our tuner and hit mirror image, and then our mirror plane is going to be that line. Now we have tuners on the other side. There we go. I hope that gives you a flavor for how you can work CAD into your workflow. And like I said before, the nice thing about it is if you're also 3D printing, you wanted to try out a part to see how it fits in real life, you could just export that one part as an STL file, print it out, and then you can have the copy in your hands, lay it on things, see how it fits, see how you like the shape, that sort of thing, which is incredibly useful. And just so you know, as expected, this design changed a lot from the time that I started it and drafted it out here in CAD, and then when I got to what I was actually going to build in the physical world. And that's all just a part of the trying out and revising process. So I'll get the next video out much quicker than I got this video out. And we'll get to some actual woodworking real soon. So until you hear from me again, get out there and make something awesome.